Dark matter, an unseen force that shapes our universe, remains one of the greatest mysteries in modern astrophysics. Imagine a substance that doesn't emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. This enigmatic matter makes up about 27% of the universe, yet we know so little about it. In recent years, scientists have made significant strides in understanding dark matter. One of the most exciting developments came from the Xenon 1T experiment, which detected unexpected signals that could be hints of dark matter particles. This experiment, located deep underground in Italy, uses a tank filled with liquid xenon to capture these elusive particles. The results have sparked a new wave of research and excitement in the scientific community. Another fascinating discovery involves the use of gravitational lensing, where light from distant galaxies is bent by the gravity of dark matter. This method has allowed astronomers to create detailed maps of dark matter distribution, revealing intricate structures and patterns that were previously unknown. These maps have provided valuable insights into how dark matter influences the formation and evolution of galaxies. In addition to these breakthroughs, the Large Hadron Collider, LHC, continues to play a crucial role in the search for dark matter. By smashing particles together at incredibly high speeds, scientists hope to create dark matter particles and study their properties. The LHC's recent upgrades have increased its sensitivity, making it more likely to detect these elusive particles. As we continue to explore the cosmos, the quest to unravel the secrets of dark matter remains a top priority.